Hello guys, welcome back to Maison African Motives, still on engineering science and two. So in this platform, we shall be focusing on the mechanical drives and lifting machines. From the question paper of November 2022, we are given on 5.1 to name two disadvantages of gear drives. Okay, what are the disadvantages? Not advantages, but disadvantages. Okay, so we know these ones. There is a need for lubrication, so you just need two, so you can just list one or two. There is need for lubrication. Okay, also we can have that they are so noisy. Okay, they are not flexible, right? They are not flexible. Also they are expensive. Okay, so you can list a lot that you can have from these ones. Okay, 5.2, name the gear that ensures that the driver and the driven gears rotate in the same direction. Okay, so we are given to name the gear, okay, that ensures the driver and the driven rotates in the same direction. So we know that this one is from the intermediate gears. Okay, so we have got the intermediate gears. All right, that's intermediate gears in this case. All right, we can use this also as the idler gear, but the most important is the intermediate gears. Okay, so that's what we had in this case. Just 1 mark for that. Okay, let's check the other part of the question. That's 5.3. So on 5.3, we are given an information below them. We were given that there are three gears, A, B, and C. They engage and they have got 70, 130, 65 teeth respectively. Gear A rotates at 600 revs per minute. Calculate the rotational frequency of gear C in revs per second. All right. So take note, guys, what we're given. So let's just list. We have got three gears that we have in this case. All right. So that's question 5.3. All right. So we are given three gears. That is gear A, gear B, and C. All right. So in this case, we are given that gear A, we are given the number of teeth, all right, respectively. That's 70, 130, and 65. Okay, so we've got 70 here. So we shall have the number of teeth for A, that's 70. The number of teeth for B, which is 130. Remember, it's respectively. The number of teeth for C, it will be 65. And also, we are given the rotational frequency, which is that it rotates at 600 revs per minute, which is gear A. So we're given the speed for gear A that it rotates at, so A, it rotates at 600 revs per minute. All right. And we are asked now to calculate the speed for gear C. All right. So we need to find NC in this case, but we are told that this must be in revs per second. All right. So if it is to be in revs per second, it means we are supposed to convert the revs per minute here to revs per second. So it's per minute, where we simply have to divide by 60. So our answer is going to be in revs per second, which is going to be 10. So we're going to have 10 revs per second. All right. So we know that we can link up the formula for the number of teeth versus the rotational frequency, which is the speed. We know that the speed times the number of teeth in this case, or the number of teeth for A times the rotational frequency, which is the speed for A, must be equal to the same for B, which is the TB times the rotational frequency for B, which is equal to TC times the rotational frequency for C. Since we are focusing with the C, we can choose which of these two that we have got all the values. So TA, we have TA, NA, we have NA. So we're going to choose this one. TB, we have TB, but we do not have NB. So it is difficult for us to work with this unless we have to find NB first. But since we want to find NC, we are just going to equate these two together. All right, so therefore, we shall say that, or we can write as TA, NA is equivalent to TC and C. All right, so to find NC, what are we going to do in this case? We can simply divide by TC. Since we want to calculate NC, we can divide by TC. That means our N in revs per second, because we converted the speed for A to revs per second. So it's going to be TA, the number of teeth for A, that is 70, times the speed. Okay, so that's 70 times the speed for A in revs per second, which gave us 10 revs per second. All right, so we're going to multiply to 10 revs per second over the number of teeth for C, which is 65. So that's a 65 in this case. All right. So I want you guys to simplify properly on your calculator. Please make sure that you simplify properly. You're going to obtain something like 10, 7, 6, 9, and so on, which is in revs per second. Or you can write as rev per second like that. Okay, so still it's one and the same thing. So this is what you're going to have as the speed for C in revs per second. All right, we move on to the other part of the question, which is on 5.4. So on 5.4, we are given that there is the driving pulley of a belt drive. We've got a diameter of 130. So take note, this is the driving pulley, and it runs at 625 revs per minute. All right. Then the maximum allowable tension in the belt is 2,000 to 2,300, which is on the tight side, because it's the maximum. Okay. And the tension ratio of the tight side to the slack side is 1,5. Okay. So remember, guys, I talked about these belt drives, even how to draw, or the sketch that you're supposed to have on a belt drive. Okay, so in this case, we have the driver and the driven. Okay, so on the driver, we are given that the belt drive has got a diameter of 130 millimeters. So you can convert this. Let's just list down our information. So we've got a diameter here, which is we can write as D, small letter D or capital D, doesn't matter. So our D1 is 130 millimeters, of which you can convert to meters. Remember, milli means times 10 to the exponent of -3. So 130 times 10 to the exponent of -3 is going to give us 0.13 meters. And we are also given here the speed that it runs at 625 revs per minute. Okay, so we're given the speed, which is 625 revs per minute. So we're given 625 revs per minute, which we can convert to revs per second. Remember, per minute simply means you divide by 60. So it's going to be 625 over 60, which is in revs per second. All right, so that's what we have. And we are also given that the maximum allowable tension, this is the tight side, that's where we can have the maximum tension. Okay, 2,300. So we're given T1, which is on the tight side. T1 is equivalent to 2,300 Newton. All right. Then after that, we are also given here that the ratio and the tension ratio between the tight side to the slack side is 1,5. Okay, so this is the ratio. Remember, our tight side is T1 and the slack side is T2. So we're given that T1 over T2, which is the ratio, is equivalent to 1,5. Or you can write it as T1 as to T2 like this, which is equivalent to 1,5 as a fraction. This is 3/2. Yeah, 3/2, that's 1,5. So you can write it as 3 as to 2 like this, as a if you want to write it in this ratio, or as a decimal like this, or you can write it as 3/2 again as a fraction. Okay, so from this information, that's where now we are asked to calculate the velocity, that is the belt velocity in this case. Take note, guys, we know from our formulas for the belt drive that the velocity is given as pi dn, but do we have information that gives us that? All right, so you're going to check from this information that we have. So that's 5.41. Remember, velocity is given as pi dn. All right, where we must have this from, if we are dealing with the driver, which means we shall have as v1, d1, n1. If we are taking from the driven, which means we shall have as v2 is equal to pi d2, n2. So we have d1, n1, and t1 from this part. We just need d1 and n1. So to find velocity, that means we can use from the driver, which is pi times d, which is our diameter in this case in meters. That's 0.13 times. Take note, n being the speed must be in revs per second. If you use the revs per minute, your formula is going to be over 60. All right. But if you are to work with this revs per second, which means you're going to write as 625 over 60 like this. Okay, it's one and the same thing, or everything over 60, it's one and the same thing, guys. Okay, so use your calculator properly. You are going to obtain something like 4.254, which is the speed in meters per second. Okay, that's the belt velocity. Okay, we move on to 5.42. The diameter of the driven pulley in millimeters. Take note, we need the diameter of the driven pulley, which means we are working with, okay, if we are given that if it rotates at 15 revs per second, so we're given that the driven pulley rotates at 15 revs per second. Okay, so this is what you're going to have here. That's 5.42. Okay, let's have our information, 5.42. So we are asked to calculate the diameter in this case for the driven. We can refer this as D2. And we are given the speed that is for the driven, which is our N2, which is 15 revs per second. So how can we calculate D2? Remember, guys, we said we can have this. Okay, is this, let's check what are we given. Is this, okay, 15 revs per second. Okay, exactly. So we're given N. All right, so what we can do in this case is we know that the velocity of the belt is 4, all right, we calculated this 4,254. So we shall have this velocity also affecting the belt, which is 4,254 meters per second. All right. So we know that we can play around this information that we are given to calculate D, because remember previously we said the velocity is going to be equivalent to pi dn. This time we need D being the diameter. So our D, if we divide pi n both sides by pi n both sides, we can have the formula for D, which is equivalent to V over pi n. So we shall have our V, which is representing our velocity in meters per second. That's 4,254 meters per second over pi times n in revs per second, and our n in this case is 15. So you multiply to 15. So that's what we're going to have, guys, just a matter of substituting into the formula because we have everything in this case. So if we divide, we shall have something like 0,0902 and so on and so on and so on. Okay, but we are given that this diameter is supposed to be in millimeters. So take note, where if you calculate this diameter is supposed to be in meters from the information that you're given. So how are we going to convert now these to millimeters? Remember, milli means millimeters means times 10 to the exponent of -3. So for you to convert, I told you guys that it's the opposite of what you're given. If you want to convert to millimeters, which is times 10 to the exponent of -3, you do the vice versa. You multiply your answer by 10 to the exponent of 3, which is a positive. So if you multiply by 10 to the exponent of 3, the answer that is showing on your calculator, it is going to be 90, 273 and so on and so on. I'm referring to the values that you obtain on your calculator. So this is going to be the diameter in millimeters. Take note, it was in meters. We converted to millimeters by multiplying by the inverse, which is now 10 to the power of 3, not 10 to the power minus 3. We know that milli means 10 to the power of minus 3, but for you to convert now to millimeters, you multiply by the opposite, okay? So if you round it off at this point, I want you to see something. Let's say you round it off your diameter at this point, you obtained your diameter as 0.09. If you round off to 3 decimal places, it's going to be 0.9 meters. If you have rounded off at this point, that means when you multiply by 10 to the power of 3, your answer is going to be 90 millimeters because you already rounded off. But if you are using the value as it is on your calculator, then you multiply by 10 to the power of 3, that value that is showing on your calculator, then you're going to obtain this as your answer if you round off to 3 decimal places at the end. All right, so this can be a different presentation actually that you can have. So it depends with how you rounded off your answers. Okay, the other part on 5.43 was calculate the power transmitted, and that is 3 marks. What is going to be the power from this information that we have? Okay, we know that for us to have power, we are going to work it from the effective velocity. Okay, the effective force, okay, that is the effective tension or the effective force. We know that power is equivalent to, so that's 5.43. Power is equivalent to the effective force times the velocity. Okay, where the effective force is the difference between T1 and T2. So power can be equivalent to T1 minus T2 times the velocity, okay, which is in meters per second. All right, previously we are given T1 in this case. If we saw from that information that we listed before, we have our T1, which is 2,300, but we do not have T2, okay. So to find the T2, we are now going to use this information or this ratio that we wrote before. Remember, I referred to this ratio when listing the information. So we can say that since we are given that T1 over T2 is equal to 1,5, for us to find T2, we can simply work out as an equation, okay? If you are to cross multiply, this is going to give us T times 1, that's T1 is equal to 1,5 times T2, which is 1,5 T2. Remember, you want to calculate T2, you already have T1 here, so divide by 1,5 both sides. All right, sorry, we need T1. Let's substitute T1 before we divide. We have our T1 here, so we can substitute this T1, which is 2,300, okay? Then we can divide by 1,5 both sides. So if we divide by 1,5 both sides, that means we've got T2. All right, so that is 2,300 over 1,5, which is going to give us something like 1,533 something 3,33333 and so on. So to 3 decimal place is going to be 3 there, Newton, okay? Or as a fraction, it's going to be 1,533 and a third, okay? So that is what you're going to have for 4,100 over 3, like that, 4,600. So it can be 4,600 over 3, of which it's best for you to use it as a fraction like this, 4,600 over 3. Okay, so we have T1, we have our T2, which we said we can write it as a decimal or as a fraction. Okay, so now we are going to substitute these values into the formula. The velocity, we calculated that one before also. So we can have our formula, from our formula, P is equal to T1. Remember, our T1 was 2,300, okay, minus T2. I'm just going to use a fraction, but you can use that decimal, okay? So using a fraction, we say the same as 4,600 over 3, all right, times the velocity, which we calculated previously. Remember, our velocity here was 4,254. So you multiply by 4,254. So if you multiply this by 4,254, we are going to have the resultant power. Okay, so that's you guys and your calculator. You must obtain something like 3,261,4, okay, which is the power in watts, or you can convert to kilowatts, which is going to be 3,261 kilowatts. Remember, kilo is 10 to the exponent of 3. So to convert to kilowatts, you multiply by the vice versa, or the inverse, which is 10 to the exponent of -3. Your answer is going to be in kilowatts, or you can just leave it like that. Okay, let's see this. If there is an instruction, because sometimes you might be given, okay, the question is just calculate the power transmitted. So there you are not restricted to use in watts or in kilowatts. Okay, 5.5, make a neat labeled line sketch. Okay, it's a line sketch of a Weston pulley block lifting machine. Okay, what does a Weston pulley block look like? Okay, so this is what we have. Let me just share the screen so that we can see what we have in this case. All right, so we are going to have something of this nature. All right, so that's what we had. 3 marks for that. So that is the total for everything that we had, guys, from this person on mechanical drives and lifting machines. So revise as much questions as possible so you can obtain the 3 marks. Just know the sketch and so forth. So the marks are actually for the diameters. You must show the difference between the inner diameter and the outer diameter, the effort and the load. There you obtain the full marks. Okay, so that's what we actually had, guys, from Maison African Motives on engineering science N2. Till we meet again.